Alright, in this lesson we will continue practicing calculating compound probability. And again, compound probability is when you have two or more events that are happening, and it can be either an AND situation, so you're trying to find the probability that event A and event B happen, or it could be event A or event B. Okay, sometimes you're dealing with two events that overlap, like these do. Alright, they have something in common. But other times you're dealing with two events that are what you call mutually exclusive, because they don't have any overlap. They share no outcomes in common. And so we'll treat those slightly differently. Overlapping, mutually exclusive, a little bit different. Alright, so here's what it's going to come down to. When you have mutually exclusive events like this with no overlap, to find the probability that A or B will happen, all you need to do is add the individual probabilities. So the probability of A or B, which is the same thing as the probability of A union B, alright, is just going to be the probability of A plus the probability of B. Common sense. If we want the total yellow, all we have to do is add the individual yellows. So that's for mutually exclusive. Simple. Now, for the situation of overlapping events like this, it's almost the same, but with one small tweak at the end. Alright, so if I want the probability that event A or event B will happen, you're still going to add the individual probabilities. However, you must remember to subtract the overlapping part. Alright, that's the key. I'm going to say it again. When you have an overlapping part, if you want the union, alright, if you want the total area of both, you have to subtract the overlapping part to fix the fact that it's being added twice. Because if we say, let's look at the probability of A plus the probability of B, well, the probability of A included this overlapping part. The probability of B included the overlapping part. So that's being double counted. So you have to subtract the overlapping part. That's what this is. The probability of the intersection of A and B is the overlapping part. So you just have to subtract that, and then you're good again. So that's going to be the bottom line. So let's get down to business. Problem number 1. So given the Venn diagram below, with set A and set B, determine the following. Okay, what is the probability of A intersection B? Alright, we need to make these connections as we go along. When you see that symbol facing down, that means intersection. You should be thinking the word AND. Okay, this is A and B. That means we are talking about the overlapping part right here in the middle. Okay, so A and B, we're talking about the overlapping part. Alright, so that's what we need the probability of. And so remember, in general, when we're dealing with probability, which is what this P stands for right there, we are doing what I like to call target over total. Probability is equal to target over total. Okay, so in this case, the target is the overlapping part. So how many outcomes are in the overlapping part? 2. I see 2 outcomes there. So when we do our target over total, the target has 2 outcomes. Alright, now the total, we have to count them up. Alright, this rectangle represents the whole universe. So let's just count them all. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's a total of 18 outcomes in the universe. Alright, so that's going to be target over total will be 2 over 18. So that would reduce down to 1/9. Okay, please be prepared to write that as a decimal. Alright, 1/9 is the same thing as 0.1111. Always use 4 decimal places for your probability. As a percent, that would be 11.11%. Alright, so that's the answer for A. Okay, let's move on to B. I'm going to change to purple to keep it separate. Now this symbol, of course, is the symbol for union, and the word for that is OR. So we want the probability of A or B. So when we are dealing with A or B, instead of just looking for the overlapping part, we are interested in everything from both circles, all of it. A or B means anything that's in A or B. So anything in A or B. We'll include it all. Okay, so this yellow represents A or B, the union. So this is what we want the probability of. Again, target over total. The target is the area that I just shaded. So how many outcomes do we have in that area? Alright, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 outcomes in the union. So that's our target. So 13. Alright, out of a total of 18 still. So 13 out of 18. I can tell that does not reduce because 13 is a prime number. 13 over 18. Okay, it doesn't reduce. But as a decimal, that's 0.7222. Which as a percent would be 72.22%. Alright, please be comfortable writing it all 3 ways, because I should be able to ask you for either version and you should be like, no problem. Okay, so that's A and B. Now let's move on to C. Now this little line over the top is another way of asking for the complement of set A. Alright, it's the same as when we use this symbol. Alright, either way it means not A. Okay, so let's deal with that. So we want not A union B. So let me do a little erasing here. Okay, now remember, not A is everything outside of A. Okay, so this is not A is all this business right here. Alright, so this is what not A looks like. Alright, everything in the universe except for A. Alright, just A is whited out. Now, so we want the union of everything I just shaded in yellow, because that's not A, but we also want to combine that with everything that's in circle B. Now, looking at this symbol in between, alright, this is another union symbol. Alright, I'm going to switch to blue. So once again, this means OR. So this means we want all of it, not just the overlapping part, but all of both. when you have this symbol. So we want everything I just shaded in yellow, but plus we want everything that's in circle B. Now I'm not going to start over again because most of circle B is already shaded in, but I want everything in circle B. So all I really need to do is go ahead and shade in this extra part as well. So I will have not only all that good not A that I had going on, but if I just go ahead and include this little piece right here, I've also got all of B as well. Okay, so now this is the union of not A or B. Okay, so I just have to leave out just this part that looks like a cookie with a bite taken out of it. So this is what I want. So now the probability is going to be target over total. So everything I just shaded in yellow, that's my target. So how many are there? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 outcomes in the yellow part in our target. So when we do target over total, okay, we're talking about 12 over 18. Now that can reduce because both of these are divisible by 3. Okay, which you should not need a calculator for, but just in case. Alright, 12 divided by 18. They're both divisible by, I'm sorry, I said they're both divisible by 3, which was true, but 6, they're both divisible by 6, so 2/3 is what it reduces to. So that's going to be 2/3, which as a decimal is 0.6 repeating. Okay, you can just toggle it. It's 0.666. I'll put 7 because you got to round that last one up. So 0.6667, which is the same thing as 66.67%. So this will be the answer to part C. Okay, now how about part D? Alright, so we want the intersection of A and not B. Let's see, let me switch over to my next color. I think I'll just use gray. Alright, so see how it's upside down? So this is going to be and, which means we want the overlapping part this time. So, alright, I'm going to have to redo my coloring completely. How much of this do I want to be? No. Okay, you know what? I'm going to start with the not B part because that's almost, that's a lot of the same shading is going to happen. So, I'm actually going to start with, this first. Alright, normally I go left to right, but it doesn't really matter the order. So this B with a little line over it is not B. So I'm going to start with that. Okay, so I'm going to convert this shading into not B. So I need to get rid of all this shading that's inside of B here. Okay, I got to get rid of all this garbage. Alright, it's a lot of, alright, I'm going to have to redo a lot. So, okay, I'm going to do this off camera because it takes a bit. Alright, so the area that I've shaded in yellow represents the probability of not B. Okay, it's everything that is not B I've shaded in yellow. So we definitely want that. Okay, but now let's see what's the other part of this. We also want A, but we have to be careful. Whenever I do this, when we have the intersection, this is when I use two different colors. If I wanted the union, alright, if I wanted A or B, I would just do them both in yellow because I just want it all. But when I want the intersection, I want the overlapping part, I'll do one in yellow and one in blue. So that way it'll be obvious because the part that we want will be green, because that'll be where the yellow and the blue overlap. Okay, so I'm going to take this yellow, but now I'm going to do A. Alright, so I'm going to shade in area A. Oh, my picture's getting away from me a little bit here. Okay, so area A is, of course, this circle right here. This entire circle represents area A. So I'm going to go ahead and shade that in. Alright, the whole circle. Okay, so this is area A. Okay, so everything that I had shaded in yellow, that was not B. And now I've shaded in blue was A. So now I want the intersection or the overlap between circle A and the not B zone. So like I said, everything that you see shown in green now, that is the overlap. So just look at the green area, and that's our target. So back to probability. We're supposed to do target over total. So looking in this green area, how many outcomes do we have? 1, 2, 3, 4, 5, 6. So 6 over 18 is our target over total. Alright, it's getting a little glitchy, but we must persevere. So 6 over 18. Now 6 goes into 18 3 times, so hopefully you don't need a calculator to see that this will be 1 over 3. Alright, 1/3 as a decimal is 0.3 repeating. So 3333. And as a percent, of course, that would be 33.33%. So this gray will be the answer to D. Okay, any questions? I can't hear you. Speak up. So that was problem number 1. Alright, so now look at problem number 2. Suppose 80% of people can swim. Suppose 70% of people can whistle. Suppose 55% of people can do both. What percentage of people can swim or whistle? Okay, I feel a Venn diagram coming on, don't you? Alright, to make it easy to remember what we're dealing with, let's label the first set S for the proportion of people who can swim, and let's label the second set W to represent the proportion of people who can whistle. Alright, and then we've got the proportion of people that can do both. Now, here's where the formula that we were talking about is really going to be helpful. These are overlapping events. So if I want the probability of A or B, okay, the union, then I'm going to add the individual probabilities, but I have to remember to subtract the overlapping part. Okay, so that's what we're going to wind up doing on this problem right here. So 80% of the people can swim. So I have to be careful sort of how I write this, because here's what I'm not going to do. I'm not going to put the 80% right here, because that looks like I'm just talking about the part that's on the outside of W. Okay, 80% represents the entire swim circle, not just the outside part. So I'm going to be really careful not to do that. So instead, what I might do is maybe I'll just put a little arrow sort of pointing at it. All right, so 80% of the people can swim. All right, so the entire circle S represents 80% of the people. Okay, 70% of the people can whistle. All right, so again, I'll just do the arrow because the entire circle represents 70% of the people. Now, 55% of the people can do both. I can go ahead and put the 55% right in here because that is very clear that it just represents the overlap, because that's the people who can do both, whistle and swim. Okay, now what percentage of the people can swim or whistle? So see that word or? All right, that's what we're dealing with when we say A or B. We're talking about the union of all. Okay, and the easiest thing to do when you have these numbers given is to use this formula. We'll do the probability of the first event plus the probability of the second event minus the overlapping part. So it becomes really simple if you think of it that way. All right, so the probability, let's see. So the probability of both. Okay, so what's, I'm sorry, I'm spacing out a little bit. What percentage of people can swim or whistle? So what percentage of people can swim or whistle? I mean, I could have just put or in there. It's the same thing, whether I put the union symbol or the word or. Either way, it means exactly the same thing. So, like I said, if I want to do this, the formula says we can take the percentage of people who swim, okay, that's the 80%, and we can add the percentage of people who whistle, okay, but we can't stop there because we've just counted this overlapping part twice. So we need to subtract the percentage of people who swim and whistle. Okay, we need to subtract the overlapping part. Okay, and here I used or and then I use and, but yet in the formula I have the union symbol and the intersection symbol, but they mean the same thing. So I could have said union here, and instead of saying and, I could have said intersection. All right, either way it means the same thing. So anyway, we have these numbers. So if I want the probability, the percentage of people that swim or whistle, I'm going to take the 80% and I'm going to add the 70%, and I'm going to subtract the 55%. Okay, and that should be the percentage of people who can do either thing. All right, that's the union. Okay, if I shaded it, we'd be talking about, whoa, glitchy. If I shaded it, shapow, we'd be talking about that. All right, all of it is what we're finding now. So let's see, 80 plus 70 minus 55. We really shouldn't need a calculator for this, but just in case. Okay, that is 95%. So 95% of the people can do at least one of these things. So that's the answer to question number 2, is 95%. Okay, and that's what that formula was all about. All right, let's move on to number 3. At Roswell, 80% of the students carry a backpack or a wallet. Interesting. Interesting. 40% carry only a backpack. And 30% carry only a wallet. If a student is selected at random, what's the probability that the student carries both a backpack and a wallet? Whoa, this is a really interesting problem. Alright, let's get our Venn diagram going again. So, obviously I'm using W to represent the percentage of students who carry a wallet, and I'll use B to represent the percentage of students who carry a backpack. And this would be an overlapping set because some students might carry a backpack and a wallet, so it's definitely an overlapping set. So they're giving us different information this time than they did last time, but I bet we're still going to use the same formula right here. But for now, they said 80% of students carry a backpack or a wallet. So there's that word or, so important. That word or goes along with union, okay? That means when we say or union, we want all of both sets. So that's what I have highlighted here in yellow. So everything here yellow represents the 80% they're talking about, all right? Wallet or backpack, okay? All of it. So I think I'll just indicate that by like putting a bracket and writing 80%, okay? So all of this yellow represents 80%. So let's see, we'll come back to that. 40% carry only a backpack. Okay, so remember how I was careful to put like the percentage on the outside before, because the percentage represented the whole circle, so I didn't want to put it inside where it looked like it was just this part. Well, this time it's the opposite, because this time 40% carry only a backpack. So I'm going to go ahead and definitely put the 40% right in the picture. Okay, right like that. Alright, because this 40% only represents like this cookie shaped, this part that looks like a cookie with a bite taken out of it. Okay, I got really squiggly there, but whatever. Close enough, can we say? OCD. Okay, this 40% just represents this part over here. Backpack only, no wallet. Let's see, what else? 30% carry only a wallet. Maybe I'll switch colors though. So I will put the 30% over here because this represents the only a wallet zone. No overlap. Okay, so this 30% represents just this part of the picture. Okay, that I just outlined right there in purple. Okay, it does not include the whole circle, just this part. So if a student is selected at random, what's the probability that the student carries both a backpack and a wallet? So we are looking for the intersection right there. Okay, now do not think that I can just subtract these from 80. Okay, don't think that actually I can just subtract these from 80. The way this is broken down, because 80% is the whole union, right? 80% is everything that's highlighted in yellow. And this 80% is made up of just these three zones. So we've got the 30, we've got the 40, okay? So, so 30 and 40 make 70. So that means this other part, let's see, can I just erase this? What color should I use? Maybe just black. Should I use black? Yeah, I think I will. This has to just be 10%. Okay? 30 plus 10 is 40%, plus the other 40. It has to all add up to 80%. Okay, so that's it. Once you have the Venn diagram broken down like this, it's really quite easy. So the answer to the question is 10%. Okay, so we didn't really have to go to the formula like I thought we were going to. All right, maybe another problem. So number 3 is done. Let's see, how much more is there, because this video is getting kind of long. You know what? I don't care. This is just going to have to be a long video. All right, we just have a couple more problems. I'm not making a whole other video just for 2 problems. We're going to suck it up and deal with it. All right? Well, that's what's happening. So look at number 4. Using the Venn diagram below, explain which situation is mutually exclusive and which one is overlapping. I'm really straining not to say duh, because that sounds hurtful, and I always try to be helpful, not hurtful. Okay, you students at home, if I could teach you one thing, forget about math. Be helpful, not hurtful. Anyway, clearly, based on what we talked about before, you know, overlapping events overlap. Okay, you know, they have stuff in common. Mutually exclusive events have nothing in common. So, I'm not even sure how to explain it because it's so obvious. So I'm just going to put some arrows on here. Okay, so this situation is overlapping. They have the King of Hearts in common. Okay. Whereas this pair of events over here are mutually exclusive because they don't have anything in common. Alright, let me change colors a little bit, and I will say these guys are mutually exclusive. Nothing in common. Okay, so yeah, that's all there is to that. Definitely glad I didn't make a whole nother video just for this nonsense. Maybe the last one will be that easy and I can go have ice cream. My wife brought home some kind of Heath bars, where they're Klondike bars, but they're like Heath bar flavor. Delicious. You should go get some, but not too many, because you know, a lot of sugar and fat. What was I talking about? Use the Venn diagram below. Find the following probabilities if 30 students were surveyed. Okay, so we're just finding the probability. So probability of French. Okay, 30 students. So first I got to make sure, like, you know what, it doesn't matter. Probability is target over total. Just keep that in mind. The probability of, you know, any event is going to equal the target divided by the total. Okay, now this ink is too big. Let me go down a bit. Yeah, that'll do. That'll do, pig. So if I want the probability of French, that means French is the target. So, French, okay? Don't say 9, because I know that's what you were thinking, because I can read your mind through the computer. 9 does not represent all of the French students that we're talking about, whatever, French speakers, something, speakers, let's say, because the French zone is this entire circle, the 9 and the 7. That's 16, not just 9. So for the French, we have to go with the 16. So target over total is 16 over 30. All right, don't worry that these numbers, never mind, they do. Never mind, I said nothing. So let's reduce this down. So 16 out of 30 is going to reduce down to 8/15. So we must do that, 8/15. And let's also express that as a decimal, 0.5333. Feel a sneeze coming on, don't be scared. Alright, let's also be comfortable writing it as a percent, which would be 53.33%. Okay, we show these probabilities in all three of these forms. Be comfortable with all three. So, how about the probability of only French? Okay, remember that 9 that you were getting ready to accidentally use? Now's your chance to get away with it, because the 9 represents French only. Okay, so that would be 9 over 15. That also reduces. Alright, 9 out of 15. Both divisible by 3, so that's 3/5. Alright, so what's that, 0.6? Okay, so that's 0.6, which if I move the decimal point twice would give me 60%. So this would be the answer for B. Okay, now how about the probability of French or Spanish? Okay, there's that word or. Okay, it goes along with the union. This is the one where we want all. Okay, we want it all when we do the or. Okay, we add them, we add it all up. So French or Spanish. So that's everything. All right, French or Spanish is the whole kit and caboodle. 9 plus 7 is 16 plus 14. It's 30. It's all 30 students. It's the whole sample space. All right. By the way, I really should draw a rectangle around this. Okay, you should always put a rectangle, around your Venn diagram to show that this is the universe. All right. So the probability of French or Spanish, the target is all of them. That's 30. So target over total, that's 30 over 30. Okay, that equals 1, which as a percent is 100%. That's a 100% probability. Okay, so there is no fraction really, because this reduces down to just 1. So yeah, it's a 100% certainty of picking somebody that speaks either French or Spanish, okay, based on this sample space, okay, because these 30 students all speak a foreign language. Well, you know, they all speak either French or Spanish. Anyway, last one. What's the probability of picking a student that speaks French and Spanish? Okay, target over total. I meant to change colors last time, but I didn't. feel foolish. French and Spanish, okay, we're talking about the intersection now. We're talking about the overlap now. Okay, so 7 is the target. So 7 over 30, target over total. 7 is a prime number, so that will not reduce, but I would like to know the decimal form. Toggle it. 0.2333. Okay, so as a percent, we move that decimal twice, so that'll be 23.33%. And that is the answer to part D, which makes it time for me to go get some ice cream. I think I've earned it. I think you've earned it. All right, if you have some ice cream, go get some. All right, there, I said it. I hope this was helpful to you guys. I hope you learned something, and I will see you on the next video. Remember, if you're watching this video, you're one of the good ones.